Don't try it.
Yeah, don't try it. Anyway, with no further ado, I'm going to bring up the first presentation, which is Marie.
Oh, there it is. Okay, well then people missed my whole introduction. Hey, open source. Okay, so also network management decisions. I'm helping at least one colleague from China right now who is looking very much into content protection and everything, and we want to make sure that we can also add this in some of the decisions. We want also to make coding decisions based on time and not just instantaneous network conditions. There are some people who study network traffic who actually know that at certain times there's more congestion or there's less traffic that would allow us to make better decisions. And essentially the time since you've been stored in the cache could also be helping on a decision. Do you need to re-encode, or I haven't signed it, so leave it out. So essentially how the coding is performed. We also want inherently it to be a per hop concept. We want it to be a network code and add with my friend Muriel calls cold composition. And we do not want, like some of the suggestions that were made on the list, we do not want to transmit any coding coefficients, but a function that will allow us to recreate coding vectors at each coding opportunity. And if anybody in the room doesn't know what a coding vector is, you can actually Google it. There's actually Professor Ferguli's tutorial is pretty cool. Next. I'm getting out of time already?
No, I just wanted to refer everybody to the taxonomy draft that we have. Just Google or search for NWCRG taxonomy, and we already have that discussed, and pretty much it.
Some of the header fields that we started thinking about, a timestamp to capture the time that the packet has been created, and it may be refreshed at each coding opportunity. We're looking for, and I see Morten coming, say this is not possible, or it's not been done, or we've already implemented it.
Morten Petersen. No, I have just a clarification question. You talk about a framework. How do you differentiate this from a protocol? I mean, what is? I mean, is it the same?
Okay. For me, a framework is an instantiation of a protocol. So it's not just a code. It's actually the code plus everything you need to put that code in the internet. And so I call it a framework, but it is, I would say, a set of protocols or an instantiation of a set of protocols. Anyway, so. I think the big thing that we like in our implementation is this idea of having, I would say, a code point. And we started linking this to a highway. So when you receive a packet with a certain code point, you say that this packet has traveled on highway X, and you know where were the exits on that highway. And at each exit, you could take a decision about what you wanted to do with that packet, depending on when it had been created and where it had been created and what exit on the highway it took. We're working on that. It's not, we can do it with a few things. We still need to generalize it, but we kind of like that. Next one. So there's also, this is actually a heads up for with the next some next conversations that Vincent is going to talk about later. There's this idea of having a network coding research group header format. I'm the one on the list who said that at first I was completely against it, and then, well, we started looking at it, and maybe there's some cool stuff that could be done if we make a common header that is very short and allow for protocol-specific extensions. I'm all for that, actually, because then my big issue with the first one was actually sending codec vectors in the header. If you want to do it because your protocol needs it, fine, I don't need it. So anyway, we want to make sure also that it's compatible with existing application layer coding, and I think Jonathan in his Tetris will actually say that he's actually also very for something like that. Next. So the known issues, obviously it's our beautiful code point. We can do it with a number of hops, at least conceptually, but we know that at one point when we merge paths, so Highway 42 meets Highway 95, what's going to happen with the code point? We're thinking about ways of doing that. The timestamps, obviously, to what granularity do we want to go? We know that there's some people out there who want to use some of these timestamps or similar timestamp to do also congestion control measurement and available bandwidth, so we may want to use these timestamps for more than one thing. So then the granularity would have to be smaller than what we had expected to do. Yes, Aaron.
Hi, Aaron Falk. I just want to point out that the term code points collides with the term in the IETF. That means something completely different.
Okay,
so if you have a field and IANA manages the field, the allocations of different values in that field are called code points.
Actually, from FEC frame and RMT, we actually do have registries for code points for FECs, and I think we are talking about the same thing here.
Then I don't understand what you're talking about.
Okay, well, I will be. But I think it's a good. I think it's a valid comment because I myself, I'm not sure that I'm still going to call them code points for long. So I may call them something completely different. Oranges, whatever. But in my brain. So go ahead.
Yes. So we have some of existing code points, for example, that identify FEC encoding types. What we may have happen under this work is maybe we will identify some new code points that will need to be registered with the IANA if we go down a route like this.
Okay. I thought Marie-José was talking about points in a network topology where you can make network coding decisions.
No, no. The code point identifies the path. The nodes themselves, I haven't identified them yet. And I will at one point. This is almost the idea of the week award. No, not more than the week, but I would say it's pretty new. So yes, it's still very early. It's at the concept and research stage, and I think with the resources that both Vincent and I have to put on that, that's why we're putting in the open, because we're looking for help. And I think we want to link it again to the network coding architecture. We want to stay away from the IPR problems. We want to stay away from all the licensing issues, but we really think that we strongly believe in this. So future steps. We want to continue the development of key concepts. Just talking to some people this week here has made me really think some more. I had put it under my name because I didn't know if the network coding group wanted to be associated with it, so that's a question to the chairs. We want to continue on the concept. So I know that the Tetris group is going to present another framework, and we want to make sure that we're compatible with them also. And also to the FEC frame that we believe is a strong heritage for us. We would like to start some software implementation. Tim Shepard's not here, but he had told me he was going to help me. But anyway, so maybe start looking at some forms of at least implementing some of the key ideas of that. Some of the transport architecture. I'm actually active in TAPS. I've been asked to be active in ICNRG and see how I could further the framework and maybe eventually take it out of a network research group and put it more in a transport-related activity, which for me is, sadly, I hope, don't take it wrong, but I prefer that. And so the IPR issues for here, we do not have any IPR disclosures. We do not intend to have any IPR on this, neither licensing on the software. We want it to be free and open source. We want to ensure it remains in public domain, so we are going to very soon put a paper in archive and date it. And we want to monitor the IPR environment to make sure that we do not infringe on anyone, and if anyone thinks that we're infringing, we're happy to talk to you. Thank you.
Okay, one comment with regards to Marie's question regarding accepting this as a working group document. You submitted it as a personal draft, which is great. I think probably the best way forward on that, probably most people have not been aware, so have not read the document, so probably we need to have an opportunity for people present and on the list to read the document, and then perhaps have some discussion on the list to consider this for working group or research group adoption. And of course, consensus can be expressed on the mailing list, and we don't necessarily have to wait till the next meeting to
Okay, well,
revisit
that's
it.
why I was asking it. That's why
Yes.
I submitted it as
Yeah.
a personal,
So
because
and
if people are not interested, I'll keep it personal.
I highly encourage people to read the document and put comments on the list, and we can have a discussion and see the way forward on that. All right, great. We're slightly ahead of time, so good job. Next.
Thank you. So next talk is about patents. So that's a big question. And the motivation for that is that, in the previous meetings, we all experienced several IPR disclosures for different techniques that were presented. So next. So I know by experience that some of the people working at IETF may not be so comfortable with IPR discussion. So if it is the case, please, may I advise you to leave the room for a few minutes and come back later? Okay. I see everybody's okay. No problem. Great. So the goal of this document and this work is not to go into the details of one particular patent and to discuss whether a particular technology may or may not infringe a particular patent. Nor the goal is not either to determine, to discuss whether a particular patent is valid in front of potential prior works. That's not the goal. What we want to do is to draw a global view of the situation today. Next, please. Okay, so disclaimer and warnings first. This work is not exhaustive. The list that that you can access, there's a pointer at the end of the document, is not exhaustive for sure. That's the first attempt. And otherwise, considering the contributors, some of them prefer to remain anonymous, and as far as I'm concerned, I'm just a messenger. Okay, the fact I'm doing this presentation does not imply that I've read and analyzed and fully understood all these patents. Next. Okay, so some statistics, raw statistics. We found a total of 49 patents related to network coding. Out of those 49 patents, 15 were declared in some IPR disclosure, and so it remains 44 external, I would say, patents. Those 44 patents do not necessarily apply to what has been discussed in this working group. May or may not. I don't know. I will not comment on this. Yes.
So very quick question. So
yeah.
These are those which are published as granted. These are not, all this does not include filed but under review. Basically nothing pending.
All those patents are, what we are considering here, the 49, are those patents that are accessible today. Mm-hmm. So
they have a number.
Published, because if they are not published, we cannot.
It's the ones that have a number.
Yeah, they have a figure.
So there is more that.
There are probably more than that. We will see that in the next slide. If you go and look at the details of these patents, you will see that MIT and the Codon Speedoff totalize 22 patents out of the 49, so which is approximately 45% of the patents. The way we did the analysis may be a little bit biased. Of course, we started by considering the IPR disclosures. So those contributors who are concerned by those IPR disclosures are, of course, maybe a little bit overrepresented. But I still think it's globally appropriate because we also search the network coding keywords in Google Patent search engine. So the 49 are more or less, can be a good sample of the situation. Next, please. Okay, so now let's consider the distribution over the years. On the left, all the patents that were considered, the 49 patents. So it started in 2003, which is not a big surprise, up to last year. Maximum is in 2012. But you see that approximately every year now, since 2011, there are between 6 and 9 patents on the topic per year. The fact that in 2014 there's only one patent that we found clearly means that we cannot. Most of the patents are unpublished yet, so we didn't find them. And on the right, you will see the same distribution for MIT plus Codon only, with approximately 4 patents a year. Next, please. Something very interesting. What are the patent offices? Where those patents have been submitted to? Well, clearly the US is the first, since it totalized 28 IPR applications. Why it is so is an open question. Then China, we found 3 patents that were only applied to in China area, and then the WO, which means that this patent is put in the international database, and if somebody anywhere in the world wants to apply for a patent, then the patents in this category will be considered. So it's very important from this prior art. Those 18 patents mentioned as WO are also important because some of them, but not necessarily all of them, some of them may also be applied to in different parts of the world. So now that's just the raw, the global figure. We need to more carefully analyze, if we want to, which of them are effectively applied to in different parts of the world. But, well, anyway, we see that, okay, main IPR issues, I would say, will be localized in the US, which is in some way, for me, which, since I'm French, a good point, since I will not be necessarily how can I say? Yeah, affected by this.
So when your dynamic coding gets to the exit ramp for US, you can just turn coding off. Okay.
Yeah. Next, please. Just one example, and I won't, and that's all. One patent that I found particularly, one claim in a patent that I found particularly, how can I say, funny, if I can. Well, imagine you are implementing software like Tetris. The basic solution for that is to do that in the application user space. And of course, you will need to access the packets that are being sent in a UDP socket, for instance, or that are coming from the network. Anyway, there are many ways to do that, but in any way, you will have to use some technique, some technology to capture these packets and to move them to the user space. And basic solution for doing that is Tune, which is very convenient for that. And in one of those patents, can you in this patent application, this is only an application fortunately, but in this patent application there are a few claims that are related to the use of Tune, TAP, and such technologies to capture packet from the kernel space and to move it to the user space, which I found very surprising that such a technical implementation aspect be claimed in a patent. Okay. It depends on previous claims, so you can have a look at the details. The full list is available in Dropbox, so you can access it. You will find the non-ordered list of 49 patents with the name of the patent, with a direct link to the Google patent search engine. So you can access it immediately. You have the names of the inventors, so you have the priority date, and whether it has been declared in an IPR disclosure or not. So for sure, this list is not exhaustive, but still, it's a good start. I'm done.
Okay. While Morten's going to the microphone, I have a comment. This is my personal view. Nothing is ever done without cost, and patents are a way of applying some cost model against intellectual property, and the IETF has procedures for dealing with it. I think it's very good to have this kind of information at our fingertips, and I appreciate Vincent and his team for kind of making us aware of it. That said, one of the things moving forward with this group, and I do appreciate the delicate balance between IPR protection, both potentially helping innovation by preserving people's intellectual property and incentivizing them to innovate, at the same time also potentially stifling innovation if it's overly heavily applied. So it's definitely a delicate balance. The good news for us as a research group and for IETF working groups is typically not our decision to make within the context of the group. It's good to be aware of it, and I understand Marie's point on research having access to technologies so that we can determine if they're even worthwhile or not, particularly something that's in a very new area like this. The main punchline I'm trying to get to here is I don't think we need to revisit this too heavily and too often in the context of the working group moving forward. I appreciate the work done to provide this information, and I certainly think we should be open to occasional updates if somebody comes up with a new IPR-free coding technique, where I'm sure we all want to hear about it. And, I want to hear about IPR coding. If somebody invents new coding and it has IPR with it, please feel free to bring it to the working group and present it and follow the IPR disclosure process, and we can all move forward. I also think just because IPR is disclosed does not mean it will ultimately be held up legally, but again, that's not the concern of our forum here. There's procedures for handling that. So don't be too discouraged by IPR either. Anyway, that's my comment. Maybe I kind of covered what Morten was going to cover since he said back down. But
MIT. I participated in some of that review, not all, because I'm under tons of NDAs to a ton of other people. But I think the reason that we wanted also to show it to the group was to highlight exactly the point for our previous work, which was that we need something. Yes, researchers, it's really always easy to get licenses, but the problem is the people who fall in the cracks, and I would say the whole startup community is part of that. Startups do not do research, but startups do not do products either. And I think this list is very important for them also. And I think the reason we wanted to present it here is that then the list is also public.
yes, well, and again, that is appreciated. One thought is the point that you made in your dynamic network coding thing sort of follows the same philosophy, if you will, that we had in RMT and FEC frame about establishing a framework, not that dissimilar from what happens in the AVT forums where you might have proprietary audio codecs. As long as IPR can be contained, if you have a novel coding technique and have IPR over that, it can be used in the framework. And in the case of RMT and FEC frame, we also had IPR-free FEC codes. I do think the point that Vincent brought up, if people are patenting things like, taking a packet off of the wire, basically, we're hosed if those patents are going to hold water, because that means nobody is allowed to take packets off the wire or whatever. So, So, but we got to move forward regardless of IPR claims and use some, judgment as far as if we establish frameworks and we need to have some awareness of IPR and that sort of thing, but we can't let it stifle innovation in this form.
Just wanted to second, thanks a lot for the list. Maybe we can put it on our wiki.
If you want.
And keep updating anybody who knows.
No.
Okay.
Thank you.
Yeah, I think we're still doing okay on time, so remember, do not step outside of the tape box. I'm fine. For our protection.
Good morning. My name is Bhumip Khasnavich. I'll be talking about updates on our draft impact of virtualization and SDN on emerging network coding. So basically, I'll be covering what we have done in version 3 and what we plan to do in version 4. This is a joint work with Senthil, Evangelos, and Cedric. Senthil and Evangelos are not here, but Cedric is here sitting. So once you have any questions or comments, both of us will try to answer. Next slide, please. So as I said, I'll talk about updates since 91 and then plan for version 4. And if you have any comments or suggestion, or if you want to join our work, please send us an email. Send your comments in the distribution list. And if you have any questions, comments, we'll take it, some of it, and some of it you can take in the distribution list also. Next slide, please. So in version 3, we added what we presented in the last time related to where to use SDN and network coding and why you need to use and the first steps on how to implement. And plan for version 4 is further work related to implementation and consider the use cases which we have covered in the last presentation, network coding architecture, use case protocol, and building blocks. For example, the network coding scheme through different layers of SDN architecture. Next slide, please. So in version 3, there are some examples, typical use case in the data center and also for the storage. So we have discussed this in the previous presentation, and we will include this description in the next version. Next slide, please. So in version 3, we also included some benefits from network coding, reliability, performance, and from SDN point of view, the centralized controller. So that can provide the central knowledge about coding and possible implementation without app or stack modification. So there are some questions we are still struggling among ourselves. So the feasible and the useful to implement the reliability of network coding to improve the latency and also the cross-domain. So there are many things you can do in different ways, but nothing comes for free. There are some advantages, some disadvantages. You have to do the proper trade-off so that you can get the best implementation and the benefits. Next slide, please. So one option is to support network coding. You include only one entity has to code and decode. So you can put this coding decoding part either in the control layer or in the application layer. So can the coding decoding be implemented in the virtual function? So if we do it, if we implement it in a VM, that VM can move in different locations. What is the impact on performance? Also other approaches. So there are two papers we are looking into it. Next. So there was one presentation in the IETF open meeting. So that also we looked at it, we are looking into it, and whether we can use multiple entities to cooperatively perform the coding and decoding. So we plan to explore these and also include in the next version. Next one, please. So if you have any comments, thoughts, and suggestions or guidance, and you want to contribute, please let us know. And we look forward to your comments, suggestions to improve this. And we will continue updating it, and once it's in a shape, we'll ask in appropriate time for work group consideration for adoption.
Okay, thank you. I have two questions.
Yes.
One, are there any papers or publications or key references that you would suggest the group look at with regard to this? Or is
it's too early because lots of things are still research, as you know.
And this also, the answer also sort of answers my next question. What are the thoughts towards prototype implementation or something of implementing something in a OpenStack or something?
Yeah, so there are some implementations, but it's too early to share the results. And we have some implementation in our also for some use cases.
That's an encouraging.
So the thing is, it's not at the stage where we can put it and bring it here yet. Okay. So, in proper time, we'll bring it.
All right, thank you. Keep us updated.
Thank you. Any other questions? Thank you very much.
Okay. We're switching to PDFs. So give me a second.
So the next presentation is about some protocol and mechanism for broadcast with network coding. So this is a joint work with Ishraq Hamdouni, Oliver Ham, Claudio Greco, and Michel Kiefer. Next slide, please. So first, IPR disclosure. We don't have IPR on what we are presenting here, but there might be some IPR from others that could apply, so be aware of that, starting from the patent listed here. Next slide, please. So what we are interested in is doing a broadcast in a very specific kind of network, which is wireless multi-op network. So it could be MANE, wireless mesh network, wireless sensor network. And one application for broadcast in this network will be, for instance, reflashing the node, doing over-the-air firmware update. This kind of primitive broadcast also has been used and developed in other groups, such as in the MANE. So in the MANE, you can find the simplified multicast forwarding, which is a RFC, which does exactly that. And this is without network coding, and what we are interested in and what we are proposing here is doing with network coding. Next slide, please. So what we propose is a fully distributed protocol to do broadcast. By fully distributed, I mean that there is no node which has an unshared knowledge of the network, so it's purely on a per-hop basis. And one example of such protocol, it has been presented in this research group before, and it's also a draft. It works as follows. Every node keeps some coded payload inside the decoding buffer, and then regularly will generate new random linear combinations. So this is a classical network coding. And then the additional thing here is that there is a simplified control plane where one node is adding information about each state on the packet. So it's piggybacked. So there is some signaling which work hop by hop. So this information could be typically the number of payload that has been decoded, the number of neighbors that the node has, the rank, and so on. And this is used to help the network coding process. So in this presentation, I will focus on two things. First, the sliding encoding windows, because I think it's a valuable building blocks that could exist in this research group, and also the case of multiple source. Next slide. So, but first, I must say that we have looked at the previous presentation about the network coding architecture and see how we fit together. So this is the old slide for the previous IETF meeting, but they are still, I guess, corresponding to the current use case. So in this use case, we fit very well. The difference is that we are using more simple model. So we don't have network congestion, we don't have information about the topology, so we don't have multipath routing or splitting ratio, and we just need a little more state to exchange between the NC reliability, but we feel we are matching the use case.
Are you going to highlight the extra state, I guess?
Yes.
Okay.
So now back to the sliding encoding window mechanism. So there is one in DragonCast, which is called SU, and it's very simple. It works as follows. Every node, as I said, piggyback some of its state on the packet it generates, and here it's the index of the first undecoded payload. So as in the example of the figure, node B, C, and D, they have decoded indices up to payload 11, payload 9, and 12. And what is done in DragonCast is to try the node which tries to generate a new packet. Here it's node A. Will consider the neighbor which is the most late in the decoding process, and you will try to help it in some way. So here the node A will generate a payload with indice starting from indice 10 and up to a certain window size. So this kind of functioning is very simple actually. So there is no many decision to make. Next slide, please. So what we did in the past year is to try to generalize this building block and to make it independent from the protocol DragonCast. So this is what we are proposed. It's a CSU, so it's a coding interval-based sliding encoding window. We made it a draft, and what is new in this protocol, in this update of sliding windows mechanism, is that we are taking into account something important, which is the fact that node maybe they won't receive coded payload fast enough. So if that happens, in SU, normally some node here, it's a node B on the figure, which is in advance. We'll try forever to help the node which is late. And this is not very proper, very interesting when you are doing, for instance, real-time video or when you have a limited buffer size. So what we address is this issue in CSU, and then we have proposed some heuristic and ID, and the thing is, it's become not so easy. So I will give the example. If you have a limited buffer size, for instance, after a warm-up phase, your buffer will be full with coded and decoded packet, and then when you receive a new combination, you will have a choice between throwing old decoded packet or throwing undecoded payload with very high indices. And the choice is not so easy in our context, because if we throw all decoded packet, we can still later receive some coded packet with this decoded packet, and then we will not be able to decode them. So there is a kind of trade-off in this context. And also there's also another thing, because now the decisions are not simple. The encoding strategy itself is not so simple. So now it's possible to try to fit at best rather than fitting at best all the neighbor rather than fitting the node which is the most late. So we are proposing here also some heuristic, and to do that we need more information about the state of the neighbors. And this is how we start with. So in situ, okay, signaling is state, and state is the indice of the first undecoded payload. In situ, we have something which is important, which is threshold, which is which basically says every payload indice which is below this threshold, we don't want to hear about it again. So if this is unwanted packet, this is dropped payload. And then there is some payload which are either decoded, undecoded, or not seen in the decoding buffer. And then this is taken into account by one node. Next slide, please. And using this information of the state, the node will do some advertisement with intervals. So there are 4 intervals. Black interval are the interval of an indice which are not wanted anymore. A gray interval is the indices that are not useful for the node, but we don't harm decoding. Gold interval are the indices of the payload that will help him decode quickly some packet. And then white interval is some payloads that are still useful, but they will help only later in the decoding process. And then how to set this interval is a policy, and this can be used to implement very different heuristics. And this is a summary of how it works. So you have node Y, W, and V. They send the 4 intervals, and node U receive them and try to generate a message, and it try to generate a message which accommodates the most nodes. So basically, the message including more gold indices. So there is one question: how to set the interval and how to arrange, how to say encoding window. There is no universal answer. There are some heuristic proposed in the draft, and it's interesting. It's flexible and interesting. Yeah. So that was for the sliding window in a single source. And now another thing.
That's probably good idea. This is a question about the previous sections.
Yes, Frank Pitzek at TU Dresden. It looks a little bit also like the index coding that we did in early days, right? Where you just want to see which packets you put together. Just that in the sliding approach, you just go step by step, right?
Yeah.
But it sounds to me a lot of like what we had in index coding in the broadcast, some years back. So, just a note.
Yes. So it's basically a refinement, more information for a node to generate packet. Yeah. So another thing I want to present, it's how to do. So it's a step back from a sliding window. It's how to do indexing, how to generate an encoding vector when you have multiple sources. Normally, if you have multiple sources, one simple way will be to index all the node and then index all the packet of each node, and then this gives you a global index. And this can be used with the encoding vector technique, the usual one. But in our context, we are going fully distributed, so we don't know what are all the nodes in the network, and we don't necessarily know how to assign an index to each node. So here we have proposed a technique called Necopia, which will be presented actually in ICC conference in June, where it's very simple. We have still this encoding vector, and every node, when it generates one packet, take a random index inside the encoding vector. So of course, the downside of that is you can have some packet index collision, so 2 nodes that choose the same index. And then what we did, it's on the next slide, we did some method, some technique to try to recover the packet despite the packet collision, packet index collection. So to do that, what we need is some hash to identify when a packet has been properly decoded, and then we can use some information about content, for instance, time, position, when we are in a cross-sensing context. This is the ICC paper, and then we can do some technique like relaxation as a sequence of linear program and satisfy some technique, some constraint a posteriori. But what we did also experiment, it's on the next slide, please. It's a more brute force approach, which is called Necorpia Light, and where we only use the hash and no more information about the content of the packet. So the example here is an implementation which is done on the Riot OS for the Internet of Things, and also run on a testbed. Here it's a 10 node, but we did also experiment with 70 node. And what we do is do this. We use random linear coding. We have 10 nodes. Every node chooses a random index. Packets are repeated, and what we have at the end is, for instance, one node has the matrix, the decoding buffer, which is represented on the left. So you see there are some 1 and a lot of zeros, so everything is mixed. And then the first step of the decoding technique is to do the classical Gaussian elimination. So if we do that, everything is fine, except that we have some line where we have a 0 equals something which is not 0. And this is normal. This is actually what due to the packet index collision. And then we need to recover the packet, and to do that, actually we use a brute force technique. Every decoded packet is a linear combination of the line 0 equals something plus one of the line with with a pivot, essentially. So by using brute force, we get what is on the right, and you can see that we have recovered the packet, and we have a linear combination from the previous matrix. So, yeah. So this could be also a technique of some interest for multiple sources. So this is it. I have presented some elements for network coding in wireless multi-op network, and I will be interested from feedback from the research group or in participating in related approaches. Thank you.
Morten Petersen, I like a lot that you took the sliding window and took it out and tried to specify it separately, because I think that is the way forward, to try to decouple all these things, not to put them in one big. I didn't fully understand the last part, so if you have a reference for that, I would like to. Yes. This part here with the brute force, I think there's some quite interesting stuff there. We also been working a little bit on something similar.
Okay.
So maybe you can send a reference to the mailing list that describes this more in detail. I think I have to read it to.
Okay, so it will be published in ICC in June, presented in ICC in June, but of course I can send you or yeah.
If you have something, I won't share, so okay.
Thank you.
Thank you.
Okay, again, I encourage the group to read Cedric's draft and comments on the mailing list. This is like in the right spirit of things that we want to get into this group. And certainly if the guys that are also working on sliding window stuff can look at this in the context of that, we can possibly have this as a model for making sure that we're capturing what the sliding window framework needs to. Thank you. Okay. Okay, next we have Jingzhu, I think. I'm not sure on the pronunciation. And one note, this was also presented in the ICC RG research group, and we actually reduced the time slot a little bit here and focus on the differences there. And we had so much discussion on the mailing list that I was considering reducing everybody's time slot so that we had lots of
Thank you.
discussions.
Thank you.
Yeah.
Good morning, everyone. This is Jin Wang from China Mobile, and my topic name is combining TCP with coding in wireless network. First, let me give a brief introduction. The coded TCP.
In the box. Oh, you can hold the mic.
Oh, sorry. The coded TCP can consist of two parts. The one part is that how to combine network coding with the TCP, and the other part is how we can make the coded TCP to comply with the TCP congestion control. Yeah. As our coded TCP implementation has been discussed in the Monday morning at ICCRG. And based on the discussion, we realized that our coded TCP implementation currently cannot comply with the TCP congestion control. Here, we try to recover the packet loss in the transmission, but we cannot distinguish the packet loss congestion from the link error loss congestion loss. So I think that is my future job to repair it. Perhaps we can combine other mechanisms such as ECN to make it complicated. And then, on the other hand, we wanted to introduce, we use a different way to combine network coding with TCP in our implementation. And today, I wanted to introduce focuses on the how we combine network coding with TCP. And maybe it is our experience in our deployment. So we can directly go to the page 6 for the problem statement.
Tell me the right one when I get to it.
Okay. At this slide, it shows that the coded TCP architecture in our implementation. And this is a standard-side implementation. We add a coded TCP layer between the application and the traditional TCP layer. And we can see from the diagram that when we receive the user data from application layer, we first buffer them in the encoding buffer. And the encoding buffer consists of the coding blocks. Each coding block contains the same number of the original packets, and then in each coding blocks, we encoded these original packets and using coding algorithms. In this example, we assume that in each coding block, the number of the original packet is n, and the output of the coded packet is m. We make sure that m is greater than n in order to avoid redundancy. Yes.
Morten Petersen, can I ask just a few questions here? So you have everything as coded. Do you have a systematic phase as well?
The metaphase, pardon?
Do you have a systematic phase where you send everything uncoded first?
Yes. In our implementation, we implement both the systematic code and the non-systematic code. Both is okay. Yeah.
Okay. And then another question is, how do you deal with very short-lived flows, like few packets, or maybe only a single packet, or?
Oh, that is the question. I have not handled it. Yeah.
Okay.
So just a quick question. Since you skipped quite a few slides, probably you had them but didn't show. You code, you get application packets or data, you code first, then you pass it to TCP, or is it the other way around? I see TCP sending you both up and down, so.
We add the coding layer upward the TCP.
Above TCP.
Yeah. We do not modify the TCP stack.
Okay.
Yeah. Yes. And in this case, in our coding side, in our standard side, we make sure that if any n of m packets is received at the receiver side, it can decode it successfully. This will make that the decoding is very simple. Yes. And next, please. In order to decode at the receiver side, we add some coding headers in the TCP payload. And there listed the headers, and the important one is the original number and the coded number. These two headers indicate the number of the original packets and the number of the coded packets. So at the receiver side, we just first to check whether their number is equal. If it is equal, then we can decode the coded packets, and then acknowledges that all packets is received successfully. And besides them, the coding coefficients indicates that the coefficients of original packets involved in the combination. Yes, next please. This is the process of the coded TCP architecture, and we record the number of the received coded packets in each coding block. And in each coding block, the receiver side checks whether the number of the received coded packets is less than the number of the original packets. So if yes, so the receiver indicates that the packet received is successfully. This is the same as the standard TCP, because in this case, we cannot decode the coding blocks. So we go on and just behave like the standard TCP behavior. And then, on the other hand, if we do not, if the number of the received coded packets is equal to or greater than the number of original packets, that means we can decode successfully. And then it's a case that all packets is received successfully. Yes.
So are you assuming some specific coding properties here, like maximum distance separable, so that this would hold true?
Yes, at the receiver side, we because in the sender side, we make sure that if any N of M packets is received successfully, we can decode it successfully. So at the receiver side, we only check whether this is equal to fast reply the AC case, and then we will decode it later, in order to not introduce additional HTTs in the process.
Okay.
Yeah. Yeah. And this is the ladder diagram to show our mechanisms. This is just a simple example. In this example, we contain 4 original packets and 1 coded packets. And in the first example, such as, for example, the packet 3 is lost and the others arrive successfully. And in this case, we can decode the original packets by using redundancy, and then we reply that all packets have received successfully. At the other side, if the packet loss is high, that the redundancy cannot recover the original packets, then in this case, our mechanism fall back to the standard TCP. We rely the retransmission of the standard TCP, such as the duplicate ACK, to incur the retransmission and to repair the packet loss. That is the main mechanism.
Okay. I'm sorry, another clarification question.
Yeah.
Quickly. When I asked my first question whether coding is on top of TCP, and so basically you said yes. Actually, if it were really on top, that means that you would get a full lossless stream of data on the other side. So it's not really on top, it's somehow inside TCP modifying some of the logic. Is that correct?
Yes, it's my mistake.
Okay.
Okay. This is the mechanism that we think that the coded TCP will interwork with the standard TCP, and we define additional flag to indicate that whether the host is support the coded TCPs, and in condition that both sender and receiver support coded TCPs, we communicate with the coded. Otherwise, we fall back to the standard TCPs in order to implement increment deployment. Yeah. So next, please. This is our test environment. We have implemented this coded TCP prototype in the Linux kernel based on the 2.6. And this is in this test environment, we deploy the coded TCP on both laptops, and the 2 laptops they behave as the receiver, and the right side top labs they behave as the sender. We also install the Linux traffic control software at the sender to simulate the packet loss. And next, please. So this is the introduction of the test environment. So this is the test results. Excuse me.
Morten Petersen, just one comment on the simulation of packet loss. It's, in our experience, it will give you nice academic papers, but it's not really gonna give you anything that you can use in practice, because 802.11 will do 36 retransmissions at the physical layer going at rate adaptation, and I mean, when you actually see packet loss due to physical layer,
I agree with you, and this is just the experiment result. At the last we also have the real world experiment result, and we will see the later maybe. Okay, next please. This is our test in the public Wi-Fi, and we deploy a coded TCP server with public IP. And on the other hand, we use two lab steps which are encrypted in the coded TCPs. And we test using the FTP file to download a 20 megabit file. And this is the download time comparison between the coded TCP and the standard TCPs. It is tested in our real world network. Yes.
Morten Petersen, so what kind of packet loss did you actually experience on those links, and what were did you somehow disable or reduce the number of physical layer retransmissions, or was it broadcast frames, or was it unicast frames, or how was it?
So as for the type of the packet loss, because in the real world test environment, we cannot make sure whether the loss is caused by the link error or the congestion error. We just test in our real world, and we cannot get more information on the real world Wi-Fi point. So that is the limitation. Yes, I cannot tell more about the test environment.
Okay.
Yeah. We also tested in the LTE network, and the performance of the two of the TCP and the coded TCPs seems similarly. This is because in the LTE network the packet loss may be very low. Yeah. Okay, I think that maybe I think that all this is all of our implementation. I think. Yeah. Okay. Yeah. Finished. Is it not? Yeah.
So thank you. I appreciate you for being able to accommodate shortening the presentation. And full slides are available on the meeting materials. So please, if you haven't seen these, please take a look at them. Okay.
Yeah.
David Black speaking as Chair of the Transport Area Working Group. I don't want to restart the congestion control discussion. I think we had more than enough fun with ICCRG on Tuesday. In fact, I want to thank Jinju for recognizing that he does have severe congestion control issues in what's been done here. I did want to stand here and point out a few more things that people might find useful. This draft was also discussed in TSVWG. There is some additional email discussion on the TSVWG list that is relevant to understanding the congestion control properties, or rather lack thereof, of this proposal. In addition, that discussion pointed out that the ECN mechanism for TCP already defines a signaling mechanism to reduce the congestion window from receiver to sender. Just adding that mechanism to this work would at least render it safe with respect to congestion control. It would, however, probably erase all of the performance results. And as been pointed out, the real problem here is trying to figure out how to distinguish when loss singles congestion versus other things. Finally, like some other people, I was a little bit surprised to see the draft first taken to TSVWG and then taken to two IETF RGs. If you do that, please have the courtesy to notify the chairs of the other forums. In IETF, we call what you did forum shopping, and it doesn't impress people when it's done. Thank you.
I feel very sorry because I'm the new attender. I do not know very. I will look at for that. Yes. I'm very sorry for this.
Right.
Yeah.
Okay, thank you. And I will say this, that network coding in general is interesting, and I think it's been pointed out enough in discussion. The really hard problem here is sorting out when the loss is a congestion signal that you have got to react to versus when the loss is a link error that you want to take out via coding, and you're probably going to have to go dig into link layer specifics to do that.
I second your comments, and actually the discussion around this has sort of prompted me. The work that we did in the RMT group with the NAC-oriented reliable multicast protocol, which implements a variant of DCCP, TCP-friendly multicast congestion control, and it also does unicasts. It's one of it was mentioned in TAPS the other day, a multicast protocol that can escape into the wild to unicast. And since it is also a erasure-coded transport, it actually kind of does congestion control in a different way than TCP's window-based by using the rate-based DCCP mechanism. And we actually published a paper recently that described some results where we, I would say, misused the ECN bit. We use the ECN bit exclusively as a loss or a congestion indicator, and actually have an adaptation that works pretty well. It's not something I would propose for wide internet deployment because it presumes that ECN is enabled in every intermediate system hop along the way, and that's not something you can guarantee in the internet, so that's why we haven't really brought it to the forum. But I think in a IETF group it might be worthwhile for me to, at a future meeting, present some of that work, because I think it would increase the understanding of a relationship between coding, which is tended to deal with lossy environments, and the challenge of congestion control in lossy environments.
And still speaking as working group chair, we encourage experimentation with the ECN bits, that alternate semantics for them, particularly for research, are fine. I mean, data center TCP, for example, does something rather different with the ECN bits than they originally specified for, and they've got some use for that. So if you can come up with something clever to do with the ECN bits that does something interesting, by all means, it's a fine place to do research, and we can figure out deployment and coexistence implications later. When we first thing to do is figure out what's the right thing to do.
Yeah, one thing that and I'll show this in the work. It might be interesting to your group is that we showed that the technique does not penalize TCP any more than TCP already penalizes itself in a lossy environment when the two protocols coexist. So, anyway, thank you.
Thank you.
So, anything on the Jabber? Save? No. Okay.
Okay, my name is Morten Petersen from Aalborg University /Steinwurf. I will be as brief as possible. I just wanted to make, last meeting we discussed defining a draft for a sliding window building block, and at this meeting I just wanted to ask the research group for some input on what is the best way to do that, so if you go forward. So basically, if we have some network coding and architecture here, I try to sort of split out the building blocks, and the one that we're zooming in on is the sliding window coding. So basically, where we are coding over packets that are moving, or a window moving over a number of packets. And what we could do is also to sort of narrow in on even smaller subsets of that, like how do you manage the window, how do you represent the window, do you use compression, what do you use, right? So there are some ideas there, and if you go forward, one slide more, we've seen there's come quite a few drafts, or a couple of drafts, and most of them tend to sort of embrace everything and define the whole framework or the whole protocol. And the question is basically, what would be the best way to specify these interfaces towards the building blocks, and for us to get started on these smaller drafts that sort of split out the functionality. And I think that goes also nicely along with, if you have the space with all the IPR, the narrower we can make the blocks, the more likely it is that you can find a set that fits in your specific. So if you go forward, and I don't know if this is really the right way to do it here, but my proposal would be to somehow define a common header file that defines the interface towards a sliding, because I'm a developer, I like to have, so if we could somehow agree on a header, sort of a header file that defines the interface, which we could document in an RFC, this is just to put up something, right? I think that could be really useful going forward, because that would mean that the open source implementations could use this header file and the proprietary implementations could provide a compatible interface, which would mean later on we would be able to actually evaluate these schemes against each other. And so if you go forward, I mean, both ease protocol integration, right? If you know this is the interface towards a standard sliding window building block according to this specific spec, and again also for us to be able to run some performance evaluation, because when you look at the sliding window codes, it's really, really hard to do performance evaluation and compare two different schemes.
Marie-Josée, mon petit MIT, do you intend to put this API in open source?
Yes, I totally agree. I think the API should be just available on GitHub, BSD license, whatever. It should not contain anything but the actual definitions of the functions to call and what should be the input-output. So I didn't know if that was the way that we should go forward, and I would like to ask the research group if they think that is a good way, or whether we should make a spec that is more like what fields we have and these kind of things.
Vincent Ocaune here. I definitely agree that splitting the full protocol into small building blocks is the way to go forward. Concerning the API, why not? Maybe it's the first time we do that, but it's not the way we did in the past in RMT and FacFrame, but possible. But for sure, we need a public repository, GitHub for instance, where we put all the interesting stuff in it. API, why not? API headers, why not? But documents for sure.
Yeah, and certainly.
So it goes in the right direction. Sure. Yeah. I do agree.
With respect to the API question, hey, we're an IRTF forum. We can do what we want. We can definitely do something like that. And then if some IETF working group wants to make use of it, or sometimes even IRTF documents can have potential sort of de facto usage. So I think in order to sort of feel out the space that we need to do this sort of thing. As a matter of fact, one of my thoughts with respect to the whole space is in some cases maybe we need to take a fairly well-scoped network coding use case, like similar one like Cedric defined, and sort of as a exercise go down a path of writing a protocol specification to help us figure out what the building blocks are. Maybe in the end it's a protocol specification we kind of throw away, but that's a legitimate activity for us as a research group to engage in.
Yeah, I mean, just also to sort of just add a little bit on top of it, I was following some of the discussions in the RMCAT group and other places where they specify congestion control, and I think one problem with having just the specs is that the guys that need to do the evaluation, they are sitting with, a number of different implementations with different APIs, and they have to. So in this case, if we could agree on something like this, but it depends on the people writing the drafts, right, whether or not they would be, because there are compromises that needs to be made here, but it would make it easier for people to do a paper saying, hey, I'm going to look at sliding window this scheme versus this scheme, run a trace with, arrival rates and erasure rates, and see, just maybe in a point-to-point initially, how does it perform?
No, absolutely, and I second that, what Brian was saying, and you, and actually I tried to start this whole discussion sometime last year to see if we can do some simple, start with a simple example and use case and do some kind of interoperability. But it's kind of a jumping, on purpose I was jumping ahead just to push everybody, try to focus at least a part of our brain to the more applied, aside from all the research talks that we had. One point I wanted to make here is that this is great. I would like to have, personally, but maybe others might have similar opinion, to have it a little structured in parallel or some clearly connected to the architecture and the building blocks, rather than jump it straight into the code. But I think that's what you meant, I suppose.
Yeah, I don't want to define a protocol here. This would be focusing just on effect block, right? Where, what has been done also in RMT and these kinds of things, and then what is the minimal API that we can come up with that allows us to move the window and all these kinds of things.
So API depends on really the information, and that's what Vincent and myself and others call the signaling. So, and signaling depends on what the high-level logic framework. So we need to kind of make it together.
So, let me propose then that I try to make a header and a small document describing the input, output, all this stuff, and then share it to the list and we see.
And actually, a personal lesson learned from the RMT experience where we implemented a new protocol, and we purposefully did not really engage in developing APIs because that sort of seems to be a typical IETF thing to do. Although I think we're seeing a little change in trend in that in the IETF. In retrospect, I wish maybe I had more. We had more activity in that area because, like with the norm protocol implementation, I've sort of been on my own to kind of create an API with a small but growing set of users, and it would have been nice to have had maybe some early engagement with other people to get more ideas and input into that. And I'm encouraged to see you thinking about this kind of thing here. Yeah.
again. The API issue is really important because I'm also doing things with TAPS, and this is exactly what I proposed at the TAPS meeting, was to create common APIs to access transport services. So this is like kind of related to this in some way.
Yeah, that was actually one of the trends I was referring to. You want to plug your laptop in, okay? You want to sit here or do you want to? You have to stand.
So now for the fun part, right? Right.
Okay, hello everybody. My name is Frank Fitzek. I'm presenting work that we have done in different entities. I'm now with TU Dresden, also affiliated still with Aalborg University, Code Einstein, Wolf Chocolate Cloud, just to make sure that everybody knows where my intention comes from. Go ahead. Before, I'm the last one now talking, and some of the topics have been already addressed. Nevertheless, I think it's very important that we understand where we want to put our magic juice, the network coding, in the future communication networks. I brought something there also to understand what other activities are going on besides IETF, IRTF. I brought some highlights, I think, and also understanding where we should go and link to other groups. We have heard some of them today, but maybe there are more. So at TU Dresden, I'm currently coordinator of the 5G Lab Germany. 5G is something that is, of course, the successor of 4G, but what they're thinking of is about steering and controlling 500 billion devices. And there are some new requirements, right? Massive low latency is something, right, that very fits nicely with what we are discussing here today. Security is something, resilience, okay, so resilient goes with coding. The low latency goes with the sliding window, so we are fitting nicely there. Also, the ideas of fusion of transport and storage is something they're discussing in 5G. That is not only the vision of the 5G Lab Germany, but also other 5G initiatives around the globe. And this massive number of devices and low latency requirements, they ask for mesh, right? We are going away from cellular. We will see cellular thing, but if you talk to people that are building now autonomous or driverless cars, they understand they need mesh on the highways with maybe overlay cellular network. And network coding is a key technology for transportation storage. Now, what is really interesting, also for resilient software design, and also some things that are looking into many core platforms. When you stack chips on each other, they're using network coding not from, as we do it in networks, they're doing it on the chip.
So I think this is very interesting, and this is also something that is not driven by this group. It's always nice to understand, is this just an echo, what we are producing, or is this something that comes from other people, right? So I think there's something going on besides IETF, and it's very good to understand that network coding is the key technology there. Okay, next. So now I want to go through these kind of architectures that we are discussing and seeing what we are doing here. First is point-to-point. I mean, we have seen here coded TCP and others, and we have done a lot of work there. The only advantage I see there is really the sliding window that gives you the advantage to act more quicker on these failures that TCP might normally time out on, right? It's really a question what happens on the link. And I will not go there. It has advantages for the tactile internet and the coded TCP. I think that's what is important. Point to multipoint, you mentioned something what you have done. I think that's quite a nice, interesting point. It's not so much 5G, it's more 4G, 4.5G, because you can do a lot of nice things. One of the things what we have done recently is to have a multicast live feed to 120 devices over Wi-Fi, so standard off-the-shelf Wi-Fi, and a little bit of Android stuff here together with the Codo library, which, by the way, is open. You can, from the respect of research, look into this, how it is done. You can put it on different platforms. And what you can see there, it's not only interesting for pushing data to these devices, it has already some interesting controlling and steering things that we are doing. So I put you there the link for those who cannot see the video. They can just click it. If you go one ahead. So this is, I think you have to click it. I'll go back. Okay, so I'm going back to my box. So what you see now, we have a live camera. We're holding it up and down. And when the camera comes in, you see two things. One of the things is that the latency is quite large. It's half a second between the camera and the display. This is nothing we can do, right? Because this is standard Wi-Fi stuff. But what you already see is they're highly in sync, right? Which is totally cool, because if you want to control cars on the highway and say brake now, it's good that they brake all at the same time. So it was quite impressive. I think it was running over 5 days. The only critical technical thing was USB sticks going into flames. But okay, next. Of course, wireless mesh, that is something that we have discussed here in the group a lot. We are currently in Dresden having 300 of these Raspberry Pis. In Aalborg we have 100 Raspberry Pis, just putting there the network coding and letting the people trying out a little bit.
Brian Adamson, I have one question, I guess, on the previous thing. You mentioned using Norm and other stuff.
Correct.
Synopsis of how you stack things together with that you can share?
No. Okay. There's purely orthogonal at the moment. I think if you want to put them together a little bit more cleverly, you can get more gains. But what you have seen from the result, already putting them just on top of each other is doing the job.
And I guess that was the question I had with respect to how you use Norm. Were you actually using it, doing NACing to recover loss recovery from multicast?
So I think the interesting point there is the feedback, right? We don't want to be swamped by feedbacks, right?
What it does.
We have done this, I think the video with the tablets, I think the first time 2008 with iPods, and we tried it with Nokia N810s with index coding. So we are just progressing, trying out different things, right? And I think it's the evolution path that everybody goes through once implementing it.
So just to clarify, coding is under or above Norm?
It's in Norm.
You said they are not coupled.
No, it's not that we are fiddling around. We are not fiddling around with the Norm stuff. There's Norm and there's coding, right? But it's not that we now come up with a special way of doing coding on the feedback and having special requirements on that. We are just using it.
So what comes in Norm is coded, or what goes out from under Norm is coded? That was my question.
I think that what is it? I think we are
so
doing
it's application coded.
It's on the
Norm,
application,
or
no,
is
it's on
it
the
application
It
Norm
has to be on the
coding?
application because we are running on the tablet. But Morten can clarify this maybe. Yeah, I think you can go, Morten.
Okay.
We got it? Good. Okay, so go ahead. So mesh is something, one more. I mean, that's just the picture, right? We have done there a lot of stuff. I think more interesting is now when we are thinking about something like software-defined networks. The mesh stuff links very nice to the Manet group, what they are doing. We're waiting a lot for getting some multi-path routing schemes. They're currently working on that. That is quite nice. But also a very active group is software-defined networks. And yesterday, I think those people in the group had the similar discussion as we have now. They really want to nail it down and understand APIs and so things to bring it together. What we have done there, I put there, you don't see it on the slides, I just put it here. There are 2 papers now if you really want to follow up on this. We combine now software-defined networks with network coding, if you go there, in 2 different modes. Next slide.
I would like to make one quick comment. And there is an opportunity. I'm pretty active with the MAN-A working group, and right now the working group is basically soliciting input on the mailing list for additional future charter items.
Yeah.
And so if you see things like multipath routing for those types of networks, or things that there's definitely an intersection of network coding and MAN-A in a big way because of the challenges of that environment. So there is now an opportunity if we have some sufficiently mature things that
there's a recent draft
help point that group in a direction.
Yeah. There is a recent draft on multipath routing in ad hoc from October 2014 in OLSR. So I think we are right in the time just going there and discussing with them. I think it's important that we don't go there and tell them they have to put coding in there. We just want to open the doors and say, can you make sure that when we are doing it, we need to understand some more parameters that they would normally not do into that, right? From the experience, I really would like to know how good a flow could be, right? If you have 3 different flows, what to do there and what are the characteristics of that flow. Okay, something that goes along that line, because similar question you have in software-defined networks. The good news is when we talk about network coding, most people ask us, how do you want to bring it in actual systems? And now that you have open flow, right, it's very easy to combine the Codo library with open flow. We have done that. And also another approach was to combine Codo with Click, if you go through this. One of the physical SDN testbeds is in Aalborg, where you have 16 PCs there together with an FPGA card with NEC routers. And we had done extensive research what you can do there if you have multipath, if you have multi-hop communication, what happens to TCP for certain error characteristics. This is ongoing work, but it's very interesting to understand how you currently can easily do it in the combination with OpenFlow. Next. We also have a virtual testbed that is done also together with TU Dresden and the Budapest University of Technology and Economics. What they have is more a virtualized testbed where you have individual entities that are currently running a virtual machine, and you can put any network that you would like to do with any characteristics. So what we have here is one source, one destination over 3 hubs, and there's a one SDN controller, and you can just try it out. So if you do that, there's a video for that. Next one. Oh, no, wait. No, it's not the video. First one. So what we did here in this, just to bring you also some results. So now you have these 3 hops, and we were asking, so how can network coding help there, right? And if you go through this, the first thing what you can look at is an end-to-end code, right? Then you can theoretically understand how many packets you would send, because you have to send a lot of more packets than the original packets, because on each hop some packets get lost, so that you get enough packets to decode in the end, right? The question is also, if you go back one more, the delay, how much you will spend in delay, depending on the error rates, you can also easily calculate that. If you go ahead, then you can also say, if you want to reduce the number of packets, what you can do is a hop-by-hop scheme, so you encode, decode on the first hop, when you fully have done that, you encode again, and so on. So you adapt to the error rates on all of them. That means you don't have to send as many packets as before, but you will get probably a larger delay. And then what you see also, if you do now network coding, you have the capability of doing the recoding, and this is what we wanted to investigate. So go there, one more. If you click now, is it starting? Is there a way? It goes. So what you see now is the virtual SDN testbed setup, and it's very easy. You can save any type of topology. In our case, we have here service access point 1 and 2. This is a source and destination, so to speak. You have there's 3 different nodes, S1, S2, and S3, with the controller C0. This is the physical topology. Now you have also the service structure on the left, and it's now doing a check whether this is complete, whether we could run some simulation. And now we are opening terminals in virtual machines on different service exit point 1 and service exit point 2, and what you will see easily is that you now can do whatever you want. In this case, they are opening just a video content. We have put some errors on the links, right, just to show it, and it's not surprising when you do now video transmission with some losses on that. Yeah, you will not see so much if it's not coded, right? So the next thing, what they have shown, if you can click forward a little bit. No, doesn't matter. No, doesn't matter. What you can then see, you can go back to the results. So if you're interested, I can show you. Then you can open just another topology where the encoders and decoders are now also loaded. You can see them in the service architecture between the service access points, and then it will give you the possibility to code, right, and recode on some of this stuff. What you see here are some measurements that we have done, which is the latency gain of end-to-end versus random network code and hop-by-hop versus random network code. And what you see there is a dramatic decrease of the latency by a factor of 6 or 16 even, depending on how many hops you have in your stuff and how many losses you have, depending on whatever type of network you have, whether it's wireless or wired. So this gives us a lot of good freedom now to investigate a lot of stuff. This is very only multi-hop, but you can now go multi-pass. You can do any transport over that. And this is something that we would like to bring to the SDN group, and maybe in Prague also talk about this. Storage was something, and I talked about this already in one of the other meetings. If you go there, we do the network coding, click, and for different things. I mean, currently, if you look at cloud storage, everything is single cloud, single pass. But we think about what is about if you have distributed clouds with multi-pass communication, or even better, if you have distributed agile clouds, right? One more. So the first, that was something I showed you already. There is now one more startup in Aalborg thinking about Chocolate Cloud putting distributed storage on data centers or over the top clouds, where you just take coded information into the different cloud entities and try to see whether you get a speed up into that or some security issues. Next. More interesting, I think you have one more click. This is the standard old architecture of a RAN system where you have base stations and radio network controllers and one cloud. If you click one more. So what you see now is what happens if the user is moving, right? So what we want to do is we want to bring the cloud services as close as to the user as possible. This goes along to this need for massive reduction in delays, like tactile internet, because just by the speed of light, the cloud service in the back would be too far away, right? You cannot be in Europe and getting a control device for a car that is where the cloud service is running in the US. So this shows you a little bit what we are thinking about our agile clouds, what can be done there. There's nothing in this group that I've heard of that is planning to going for an RFC, but as we also in ICN look into the fusion of storage and also transport, I think that is a nice aspect that we can bring to that. One more. Last but not least, there is an add-on now on Kodo that talks about security and integrity. I just want to go it first. Click. The first one is understanding what is if some relay nodes could really intercept the kind of information. Do we have to can we rely on the algebraic security, or do we have to put something on this? There's tons of publications from MIT, and also Porto is doing a lot of this. What you can do, we have an end-to-end encryption, SPOC, P-coding, and half. This is now implemented in Kodo if you want to test it out. That gives you another layer of security, right? Which means if, for example, for the distributed clouds, you don't want to rely on algebraic security. That means if one of the clouds are open, but if you think the NSA can go to all of the clouds, something like this should be done. And the last thing is more integrity, which is in homomorphic coding, which allows you to make sure that you are only picking those packets that were intended for your coding stream, and not that somebody is putting in malicious packets into that. That is not part of Kodo, but you can download it along Kodo and try it out. So one more. Last thing is really where should we then go with our network coding ideas? SDN is one point. ICN, we talked about this network function virtualization, is also interesting, even though, the SDN, which is a realization, is closer to us, as I see it. RTC Web or Web RTC could be also an interesting thing, because they're also talking about now fax schemes. And Mané, we talked about this in multipass TCP. They did not meet this time, but maybe in Prague we can also look at this. In congestion control, there are different groups looking at this, and I also ask the people to go there to see what they are doing. Not only TCP, but also in RDP and so on. Okay, then I leave you with the question, what we can do here in our group. Thank you very much.
One quick comment regarding your last bullet here, what can we do in our group? And if you go back to the beginnings of why, one of the motivations that we cited for forming this group was to kind of provide a home base for those with the gift of network coding knowledge, because we knew that, and we actually observed that all these other parts of the IETF were starting to look at coding here and there, and the idea was to kind of have a forum where we could take this topic and have more of a centralized knowledge repository. But all along, the approach is to reach out into these IETF working groups as things are well understood, or if they have questions, they can bring their questions to our forum to be considered. And the other one, of course, is, as we all have done, when you get frustrated from banging your head against trying to explain coding to other people, at least you can come here and have people that you can relate to.
But then my question would be, are we doing a good job in that, right? We started with this idea, and what we have now is more closed group thinking about all these questions, what is open, what is IP, but we are not really doing the ambassador for the others, right? Yeah. And this is what we should do.
I do have involvement in Mané, and the timing needs to be right to bring this into that group.
Hi, Bhumip Khashnavich. I have two questions. Can you go to your 5G slide? Yeah. So massive low latency down to 1 millisecond. I thought they have defined few other category target as well, in addition to 1 millisecond. Is that true?
There are a lot of more requirements.
Yeah.
But I just pulled out those that are interesting for us here, right?
Okay.
Method throughput could be related to multipass communication and how we can perform there. It's not complete.
It's not complete. Okay. Yeah. And the other question is, can you go to the SDN architecture diagram, Brian? Next. Yeah. So in this one, the coding is done at the intermediate nodes or at the endpoint, and how it is coordinated with the controller?
No, the coding can be done in any node, right? So it depends what you are. If you are the source,
yes,
it's encoding. If you're the sink, it's decoding. If you're any other node, it could be potentially recoding. And the controller is just understanding now where is what is the topology, right? We did not exploit it so far because it's just multi-hop, right? But in the future, if you take multi-pass, you understand the topology, it can do some tricks. For us, it's a very basic idea how you exploit coding, because you see the topology, right? That is the good news in SDN. Something that we in Mané type of things you will not see.
Yeah, but the point is, if the controller needs to communicate using the open flow control protocol, you need to modify the protocol.
Sorry, they need to?
You need to modify the protocol, because open flow, whatever they are specifying.
Oh, of course.
Yes.
At the moment, we are happy that it's running. So the first step was really bringing OpenFlow and Codo together.
Yes.
And now, of course, all of these things, but this is also part of this group, right? What do you want to tell them? And this is not our interest, but if I bring it to the SDN people, they might have already a draft understanding of extensions. Why should I come up with that, right?
Well, yeah, so we are considering some of this use case in our impact of virtualization, and we found that we need to modify that without it will create a problem. Okay, thank you.
I think you could do that.
Marie-Josée Montpetit, MIT again. I'd like to respond to the cheap shot about us not being very good about disseminating network coding in the IETF. I think we are doing an extremely good job, and I would say that if you would have come to the TAPS meeting on Tuesday, the one I stood up, FEC and coding issues are number 9. in the future elements to add to TAPS.
Yeah.
And this is huge because a lot of the people who were involved with TAPS before were not that interested in adding coding. So, and it's not the only place. The ICN people, as you know, are thinking about it. And again, one IETF before, they were not. So I don't know where your message that we're not good at disseminating comes from, because I think that's a real cheap shot.
No,
that was a question. So there's in the end of sorry. You have to understand this. In the end of the sentence, there is a question mark. This is a symbol which is more than a point. So I ask ourselves, are we doing a good job in bringing this knowledge to the other groups? And this, everybody can do an answer. I mean,
I think we should, I kind of responded and answered Frank's question. And my opinion is, I said not yet. We're definitely doing some things. Like I said, I participate in MANA, and I review what you're doing in TAPS, and I've been coming to some of those meetings too. I think there's more we can do. I think that definitely that was a start. It would be nice to get more folks from some of those forums also coming to these meetings too.
Yeah, but I think there's also an issue. You say we waste our time talking of open and everything. You just listed at the beginning of your slide a list of companies that have commercial interest in this, and how do we deal with that when you go to other people and you say, well, yeah, sure, network coding could be really cool in your application. However, where could I, so the next thing is, where could I get code to try it? And there's none. Or it's controlled by licenses that are not applicable right now. So I don't know where, again, this thing comes that we're wasting our time. We're not. We're actually trying to address the issue of dissemination.
Nobody said wasting our time. It was a question whether we are doing a good job in disseminating it or if we can do it better. And I'm totally with you that we might have better approaches. Also myself, I can see it now that I go to the other groups since two meetings, since two of these IETF meetings, understanding it. Yesterday, for the first time, we raised our hand in SDN. I think you also need to feel comfortable to do that. It's not just that you run there and say, we know it all. It's more about finding the right people that understand us also and find the right API in terms of other groups.
So may I make a suggestion to you and anybody else who feels the need to interact with other groups? Just do a little summary of what exactly,
Yeah.
Put more meat on the bullets there.
Yeah.
All for it. Everybody is all for it. So let's hit on the concrete.
Hi, Aaron Falk. So there's a couple of models of how the IRTF can help the IETF through expertise. The ICCRG and the Crypto Forum RG both are sort of centers of excellence or expertise in the IETF, and assist working groups by reviewing proposals and assessing them on sort of the intellectual merits by people who've got expertise from the research community. I think that if the network coding research group takes the approach of trying to promote the use of network coding wherever possible in the IETF, it's not going to be viewed as a credible reviewer for other proposals. And so you kind of have to figure out which of these tacks you want to take. I mean, are you going to take the marketing approach or the expert approach? And I think if you're going to take the expert approach, you need to come up with, supportable consensus documents on responding to proposals that come up in working groups. And those proposals can come from people who are in this room. But if the research group is going to try to take that position, I think that's actually very valuable, because one of the things it allows to do is it moves the sort of the academic review kind of arguments out of the IETF meeting, which lets them progress. They can sort of table it. Okay, the research group's going to come back with a review of this, and then it gives a place for people to come and have that discussion. And so, I would say that's a useful thing. If the group wants to take an approach of, we're going to try to promote the use of network coding, Then you bring a whole bunch of the commercial-related issues that I think have already come up in this meeting into that discussion on sort of, what are the motivations of the participants for doing this. And it gets, to me it gets icky. But this is your group, and you guys can decide what you want to do.
Yeah, I think that's a very good comment. And I think there's also a balance of not just promoting use of network coding wherever it's possible, but we also are trying to, through the documents they're working on, identifying specifically where it makes sense and is actually beneficial and appropriate, to provide some documentation that maybe other groups can come to and see, hey, I'm doing software-defined networking, the network coding research identified these possible advantages of using network coding and software-defined networking. So I don't feel that we should be a marketing group by any stretch of the imagination. But I do agree that we can provide a pool of expertise, and I guess you sort of said we have to go one route or the other, and I feel that there is a way to kind of balance those two things.
Well, so let me just try to clarify that I think that there is a lot of value in having a group of experts review proposals, come up with a consensus, and it can be a consensus that says, well, there's multiple perspectives on this, but I think that that's really valuable. And so, yes, separate. Maybe you don't have to make a choice, but I think if this research group was able to do reviews of stuff that's happening in the IETF, that will promote a lot of goodwill, and people will come here and they'll say, hey, this stuff is coming up. What do you guys think? I mean, that happens in the ICCRG and the crypto forum all the time.
And that's why we're doing things like establishing the taxonomy and terminology, so that we actually even have a language to even have those discussions among ourselves and with other people. So I think that's the direction. I think you articulated it better than maybe we have in the past.
But I also think that the task should be to understand who is going, what we are addressing, right? I think now with SDN we have maybe two peaks where we can go there. Encoded TCP also created some problems on the other side, right? They said, there were different versions of coded TCP, and what is the right? We did not have one version of that. It's not our fault. But some people read the one proposal, the other, and then people get confused, right? I think if we can harmonize it, and taxonomy is the first step, but also for these architecture things, right? That we understand where can we do what, right? Where is the potential, right? And I think if we have there an honest description what we can do for the other groups, which is also simple to grasp, because it's only sometimes the essence is very easy, and I personally find it easier to speak with new groups than with well-established groups that have a certain way of doing things, right?
Yeah, okay. For time purposes, I think we want to thanks for all the comments.
So hi, my name is Jonathan. I will present some updates about our draft for patent-free network coding protocol. Next slide. So the noteware. Next slide. Okay, motivation and goals. So at the first meeting of the network coding research group, we introduced the Tetris mechanism. And at the last meeting, IETF91, we presented the first version of a draft called Tetris. The recent updates are reported in this presentation and in the version 1 of the draft. And the goal of the work is always the same, having the Tetris protocol instantiation and a collection of architectural building blocks. Today, in the draft, you will find the protocol instantiation and some definitions of building blocks. The goal is to extract some building blocks to separate documents to make it reusable. Next slide. Okay, so we added a generic header packet format inspired from the coded transport header, and with a common header for all the packets, a per packet type selection, plus some header extensions. Next slide. So, as you may know, with Tetris you could create some coded packets. So the coding scheme is independent of the protocol and can change dynamically. So for example, when the network conditions change, you can change the code. With Tetris, you can do some block codes, also window-based code, and this part could be separated from different building documents for building blocks. So next slide. So here is an example of how work Tetris in an end-to-end case. So we have some source packets containing some source symbols in black. So we choose here a code rate of 2/3. So each 2 source packets we are sending a coded packet, okay, which is a linear combination of all the non-acknowledged source packets. So when I want to send a coded packet, I need some information about the linear combinations and the symbols, the source symbols included inside. Okay. So next slide. So depending on the coding scheme, you could choose to store the coefficients in what we call an encoding vector, or using the coding scheme methods to compute them. You don't need to store in this case. But you need to store the source symbol IDs. So network coding could bring some advantages, but the problem is the overhead when you store these informations. So the question is, can we reduce the overhead of this source list? Next slide. So the source list, the source ID list, is can be reduced to use some compression, so you keep the different values, or a big vector field. This is the same thing. We could extract these 2 ways in 2 building blocks, and depending on the situation, you could use a big vector field or a delta compression. So I will take an example. Next slide. So what is a source ID list? It's just a set of sorted 32-bit words. So rather than the full list, okay, here I give an example. You could send the bounds, so you divide by 2 the size, but you can also compress this new list, and you will reduce the overhead. So it's just a way. There are plenty of ways to compress a set of sorted integers. Okay. So we gave an example, just one example. So next slide. Okay, conclusion. We propose Tetris a flexible network coding protocol instance by giving the possibility to use different coding schemes. You could use block or window-based codes, and the code plus the code rate plus a lot of tunable parameters could change dynamically. And we know so many elements must be moved actually to different building blocks to align with the network coding architecture. That's all.
Bhumi Khashnavich, I have one question on the last bullet. When you move the building block to different position in the architecture, how it is coordinated and communicated so that both the endpoints and the middle point.
I think this will be the architecture document which will
So
decide that.
Yes, we still need to do it, yeah.
Just a quick question. So on the changing the codes dynamically,
Yes.
is it pretty much what Marie presented this morning?
Well, it could be that, but for example, when the encoding window size is growing, you could decide to change the code because you have a low CPU, or you could guarantee to avoid linear dependencies, stuff like that.
Yeah, but I guess you can subsume that, or basically your scheme can actually do what they want.
Yeah, you could you put what you want, whatever you want. Yes, exactly.
So,
Martin Peterson, just clarification. When you say change the code, you mean actually the coefficient generator?
Yeah, the way to generate the coefficients, exactly.
Okay.
Okay, I just have a few slides very quickly. So let's continue with the architectural discussion. We already discussed some of part of it, and what we are proposing is just in line with what Morten, for instance, already said. Okay, I guess that we have to order a little bit the work to do. I think that the first and easiest part is to finish this taxonomy document, terminology document. What already exists in this internet draft is the current terminology in the community, but we still have to put inside the agreed terminology, or the terminology to agree, for use in this working group, which is not necessarily the same, which can be backward compatible with what was done in previous IETF working groups, for instance. So I think this is something that we can do easily till the next meeting, and then agree, decide, finalize this. Morten?
Yeah, Morten Petersen, yeah, I totally agree with that, because now it seems to be like let's say the superset, and maybe we should narrow it down and figure out what is the terminology that we think, should be used. And
exactly.
Then, that's a very good point.
Exactly.
So, if I may interrupt, a couple of quick comments. First of all, I just sent on a mailing list that we actually have a group draft that supersedes that. So, please take the link from the mailing list instead of.
Oh yeah, I made a mistake. Okay, sorry.
Okay, so this is
I took the wrong one.
Yeah, this is obsolete. It's gonna be the group name, not my name. Okay.
I will fix that in
okay.
I will send you a new
No, so, just take what I sent on the mailing list. Okay.
Exactly.
So the other thing is that we spent quite a bit of time on nailing down the terminology there, and I thought we were almost, or if not, we keep asking, okay, anybody else has any more things to add, change, opinion? Of course, we had quite a bit of discussion at the time, maybe a little too much, but point is, I thought we were pretty close to being done on that. Obviously, there was no more discussion. So, if you or anybody else can point to exactly what change, add, subtract, whatever.
Yeah.
Okay.
If I understood Morton's comment properly, it's probably something about down-selecting, prioritizing the broader set of terminology that we've identified into the network. In the case that there are possibly redundant terms, what is the preferred term for the network coding research?
So when I last edited that, to taking everybody's comments in, I put that, this is the main, the agreed upon main terminology, and then parentheses, also known as that in some other papers, just to make a connection to other published papers. So so if we need to, anybody please send on an email on the comments on the list to change or improve.
Yeah. Second step, use cases. That's something we already discussed at previous meetings, so now it's time, I think, to put it all in another document. That's something we absolutely have to do, especially as it will define all the different situations, whereas you have this taxonomy, whereas you have one or multiple sources, paths, and so on and so forth. And the proposal, the protocol instantiations, will have to be clear what they address in this large set of possibilities. So that's something that can be also done. We now have almost all the potential input to write in this document.
So, all the use cases we discussed last time, just put them in words. That's what you're saying. Okay.
Next. Now, the more interesting part, maybe, signaling. Signaling is something that is extremely important. What we did in RMT, and which I think it was excellent, was to first write a document explaining what are the rules to follow and what is the signaling associated to each FEC scheme, or coding, let's call it FX scheme or coding scheme, it's the same. So those are really the basic rules that, and it is also a guidelines of how to write a FX scheme for RMT, and I think we should do the same for our working group. That's not trivial at all, because the key aspect will have to be decided and discussed and agreed before we can do that. And especially whatever concerns the identification of symbols. That's something which is not so easy, especially if we are considering the broad use case with multiple sources, re-encoding, and so on and so forth. So that's far from trivial, but it's something that we have to do anyway, and it's absolutely important, essential before we can write actual technical coding building blocks.
Yes, Morten Petersen, I think the identification of symbols on the wire probably should be, abstracted away such that it is defined within the individual building blocks, and then we simply need a way to pass information between the building blocks, because, as you say, that is non-trivial.
Sure. And then there is this part in let's try to have something which is as common as possible. The network coding, common network coding header. We try to do something inherited from what was done in LCT, coming from RMT working group. It's not finished, but I think it is a good start. After discussing with Cedric, it's obvious that he will not answer all the potential use cases, especially if you are considering dedicated embedded systems. That's definitely not the right way to do that, because you have additional constraints, extremely heavy constraints in terms of header size that will not be addressed, that is not compatible with what we are proposing here. So it will be something more for the internet general internet use case, but I think we can do something which is relatively common to different protocol instantiations. Next. So the first bullet is what I was saying, adding something different for embedded. I just forgot to mention what I meant before was more for transport use cases. Maybe we have to discuss whether it is also compatible and applicable to network use cases. That's something for the moment I have no idea. It's no point from my point of view, but we have to discuss this. Okay, so that was step 3, and step 4 is to continue with building blocks, individual building blocks. Maybe the encoding window is something we can address, since you and some of us have already a good idea of what to put inside. Maybe it's sufficiently independent from the rest, but okay. Otherwise, for other building blocks, I think it's better to wait a little bit. So that was the proposal. Create interest, of course, but I think it's now, a point we all agree on. From a methodological point of view, we need to do that on the public repository, GitHub, for instance. So we can put in this repository not only the internet draft, but also what was proposed by Morton, the API, if we want to have some common APIs for some specific building blocks. But anyway, put everything in the public repository, and having all discussions in the official mailing list. In the past, we had problems discussing between ourselves, not in the list, and then it was too late to move to the list because people on the list would miss the background of this discussion. Well, all horrible things. So if we decide since now on to have all discussions public, it will facilitate maybe the integration and the work and the collaborative work. And then we have to define milestones. I think that for next IETF we can agree to do a few things, especially for the terminology draft.
Thanks, Vincent. Just a quick observation that we do have. So from IETF we do have a wiki available.
Yeah, a wiki, yes.
I don't know. Maybe it doesn't replace 100% GitHub, but definitely sharing.
If we need to share, we need there. So, merging collaborative work. It's more than a wiki. We need more than a wiki, I think.
But
I'm not aware of something similar for IETF or IETF.
Yeah, every group has a wiki.
Yeah, but I think the GitHub would definitely facilitate collaborative authorship and drafts.
Rationing, all this stuff, all these good properties.
Morten Petersen. So I actually would probably, so for the milestones, I mean, I think stage 1 and 2 are interesting, but I would like to take a more bottom-up approach. For me personally, the interesting one is stage 4.
Yeah.
And then go in, because we have already existing schemes that we can, tear apart and look at what are the building blocks there. The other 2 are something that we may do in parallel, but I don't really see them as critical, in the same way as out of stage 4, I think useful stuff will come. Mm-hmm. And or step 4, and so I would prioritize differently. I would say let's get step 4 going and figuring out, what are the window management building blocks we can come up with, what are the window representation building blocks based on what we have now, and then we do taxonomy, architecture. Architecture is going to be something that will. It's a very it's a very open-ended document, right? Yeah. People are doing so many different things with this stuff. So even outside the context of this environment here, right?
So, So I mean, there's definitely going to be a bit of an iterative process, among these steps. And with respect to the architecture document, we'll never write a document like that that's going to be completely true or complete forever. And certainly, it'll be probably published as an informational RFC, and we'll probably have to update it over time. I think the iterative idea is an example is what like Jonathan presented with Tetris. He's got kind of everything there, but he's within his draft. He started to figure out how to break it apart into modules. And I think as a working group, we can start looking at some of these personal drafts and say, okay, let's take this document, and we sort of identified like the sliding window building block is one thing that we work on. So I do think there's going to be a little bit of a both bottom-up and top-down kind of process involved here.
Yeah, Marie-Josée Montpetit. Actually on this I completely agree with Morten. I think I had started a discussion on the mailing list that nobody picked up, and you should know that this mailing list right now is my black hole. But I think this is what I had suggested, is that essentially the architecture, we cannot really put it in cement right now, because there's a lot of things that are moving in parallel, and if going back to the comments of Frank about other working group being involved, and it means that the architecture will also evolve. And I think look at the building blocks and say, okay, so here are the building blocks and here are the architectures you can do with it. I think it's a really, really valid approach, because again, we don't really know what this stuff is going to be all used at the other end. And I think right now, while we're talking about it, I think one of the issues that maybe of the previous ones is that there's obviously a huge room for network coding and everything that I call transport, which includes storage to a certain extent. And then there's the stuff that is not transport. And I would say the architecture right now is a bit complicated because we tried to put everything together. And maybe there is more than one architectures. And for the same reason, there's probably more than one network code. So I would actually suggest, and revisit how we could make the architecture a little bit less complex right now by maybe pulling out things that we can put somewhere else.
Okay. Good suggestion. And actually, to sort of steal what Adrienne Farrell challenged another working group with her this week, is like, how many people in the room have implemented software? Raise your hand. And then how many people got their object taxonomy right the first time? It's nobody. So it is going to take us a couple tries to get this, particularly in this new area.
I mean, Morten Petersen, just as one additional comment there. I mean, maybe I'm wrong, but the architecture document for me is really not. I've had a hard time seeing how useful is it going to be, right?
You're not the audience for the architecture document. The audience for the architecture document relates to, if I'm not a network coding guy and I've heard of this thing, network coding, and I want to understand how it fits into the big I internet things like software-defined networking, I personally, I think I see the value of that. And even if it's not 100% correct, and I think for that reason, knowing that it's not going to be correct, we probably need to keep our architecture fairly loose, like we have done in these block diagrams. We have arrows pointing at things, but we don't really get into the details of what's carried on those arrows in that document. We will need to do that in the building blocks. But the architecture is more like the spirit guide for network coding.
Maybe I can clarify my thought right now.
Yeah.
So, can you give me one last question, which is actually a segue to my topic, but I'm gonna. So my personal view is that everything is fine, great. That's pretty much what I was thinking as well. The only thing, an observation here, is that I would approach step 4 kind of before step 3, or kind of either that or simultaneous rather than after.
Yeah.
Because I'm more of a top-down kind of, so let's just see the boxes, kind of how they look, and then what they require, and what they require is signaling, but also some other things. Basically, the box is, as I'm going to show now, it's going to be signals from outside and some interfaces to inside. So that's pretty much.
Yeah, we can refine.
They go together. Right.
Yeah, you can refine or have it together.
Okay.
But some of the building blocks clearly depend on the step 3 results. So some of the building blocks for step 4 clearly depends on some of the items on step 3.
Yes.
So for some of them, it
that's why
makes sense
I
to
think
delay
they go
a little bit. For others, no.
I think they go together. That's,
yeah.
All right.
Okay, yeah, so we have about 20 minutes of time left, just so everybody knows.
Hello. So this is a continuation of the slides and discussions we had last time in Hawaii. It's basically going the next level down. From the very high-level architecture use cases we had, if you can move on. So first of all, I acknowledge all the people that actually provided inputs, and this is really a group effort. So all good things are yours, all mistakes are mine. I'm not going to talk about these two, so these two slides, this and the next. I just wanted to, this is pretty much a copy, a slightly updated copy of the couple of the use cases I showed and we discussed last time. The point I want to make here is that although that these two use cases are quite different in that this first use case is a shim layer, it's not a transport layer, it's a end-to-end, not a network, hop by hop. If you go next slide, you can see this use case is the more like the complement of it, which is it's a transport. There is no other protocol between it and the application. It is an in-network coding as well. So these two are quite different applications. But what I want to point out here to notice is that let's see. So if you focus on the if you focus on the architecture of just one node and you kind of flip between the two use cases, you'll see that the diagrams are almost identical. So the point I want to make, and you can do this for the other use cases as well. So the point I want to make here is that no matter, you can do a lot of different use cases and applications with pretty much the same kind of architecture, which contains the same, that the blocks are used maybe in a little different way. Maybe the blocks themselves, and I'm going to talk in a minute, will contain very different algorithms inside, but the architecture, this is what I consider the architecture of network coding, is the structure and the relationship between these building blocks that remains almost unchanged between the different use cases. And I hope this will happen in the future when maybe we add other cases and when we refine this. So at least this is I think is more than a wish. I think it's based on some of the applications that we've heard from all of you and from my experience as well. So the rest of this will be drilling down into, this is the next level of detail that I was talking about. So what I did here is to take one, don't be afraid, this looks complex, it's a lot of stuff, please don't read much. The main thing is that this is the aggregation of all the building blocks in one per node architecture. And I'm going to, each slide, each of the next, I think, 4 slides or 5 will actually look at each of the building blocks in particular and talk about the functions that they are supposed to have
of course, there will be options into what kind of algorithms. And of course, the interfaces between them, that would be interfaces, peer interface, which is really the signaling between the two or multiple nodes, and then interfaces or internal signaling between the building blocks. Vincent.
Vincent encore. Sorry, Victor, but I hate this slide. I found it horrible.
Me too.
Because it exposes all the complexity, whereas what we are trying to do is to hide complexity by defining sub-building blocks, where that will manage all those specific operations.
I don't
see any added value in having this big picture with the details of what is doing in some coding and the coding building block, for instance, which might also be wrong in some cases, because in some cases the building block will not exactly work this way. So I would prefer to get rid of all the text and only keep the picture, which I don't perfectly.
Sure, I can do 2 slides or 3. Of course, the ugliness, no, I agree. I don't like it either. I just wanted to put it up front. We need to face the complexity. So this is us facing so this is everything put together. And I'm not going to talk about it. I just wanted to show where everything fits, and then each of the next slides will be just one.
But Victor, I think it's complex because of exactly what I said before. You're putting everything there, and I am kind of sure that there's probably very little use case that we could find that we use all of these things. And if you want to hide a few of the things and don't go into that level of details, what is the standard building blocks that we need? And move on with it, because this is like so complicated. It's almost looking like, these funny road signs that go all over the place. You cannot use this to explain network coding to anyone.
So that's not the point. The point is,
my comment, I had a little different perspective on this. I mean, the simplicity is in the diagram. Okay, good point. But for example, in the case of, say, congestion control, it's different depending on whether you're doing unicast, end-to-end, or multicast, or the kind of, what we refer to as subgraph is kind of like what Cedric presented as far as in-network coding within a portion of the network to leverage network coding, and you may have concerns about congestion control in that part of it, and it's going to be a different type of congestion control than existing end-to-end congestion control mechanisms provide for, and that's why that's one that's identified as a research thing. I think the blocks kind of hold up against it, and I think I didn't view this as a complete list. I understand exactly what Vincent said. It's wrong in for some use cases. It's not complete, but these were more like example functions that are going to possibly vary for the different use cases we identified, even though the architecture holds.
So let me also make a couple of comments related to the questions just now. The fact that this is an abstraction from all the use cases. So basically the 4 or 5 use cases were relevant to some or many of us. So the observation I made in the beginning of this talk is that this diagram is very much the same between all the use cases. So in that case, it's pretty general and pretty useful for everybody, for all the use cases. That's one thing. In terms of the complexity, I specifically looked at, actually I got inspiration from there is a similar diagram for norm building blocks. And that's, I'm going to say this is maybe a third of that, okay? So I think we're fine with that. Moreover, like I said, this is a summary of everything that I'm going to talk next, so don't look at the text. Agreed with Vincent. So let's see. Moving on. So you can see how, if you flip back a little, just one, okay. So I'm going to talk about each of the colored blocks, the 5 colored blocks, building blocks in particular. I'm not separating building blocks in sub-blocks, or I'm going to just talk this high level so that I keep the complexity low. and suggest what are the main functions and interfaces with the rest. Okay, so I'm going to start from the most simple or basic building block, which is the core. Yes.
So I do have one question. So again, my view from the other slide was that the things you identify were examples and not necessarily the entire complete set of everything.
Yes,
Because
yes,
even
definitely,
this,
yes.
The things you list here to the right are not complete for all potential coding
Agreed,
schemes
yeah.
and use cases.
So all this is a start to get us going into writing about the building blocks.
So I tend to
Right.
possibly agree with Vincent and
Okay.
Maria if we think we're going to go through an exercise where we are going to capture everything. Because
No,
I
yeah.
don't think that is going to be pragmatic and not
Right.
necessarily
Yeah.
that valuable.
Yeah.
I do think identifying the high-level architectural components and having
Yes.
a fairly
Yeah.
loose architectural description so that we can communicate to
Yes.
outside
Yeah.
parties that
Yeah.
there are these different aspects that you need
Yeah.
to consider in realizing network coding within a network system. So my concern is if we're going to try to enumerate everything, that's going to be a huge
Absolutely,
complex
yes.
task
Yeah,
and not
yeah.
very productive.
So if you go back one slide,
Yeah.
the main outcome of this whole thing will be
This drawing. It's kind
well,
of
outcome of the architecture and building would be the main functions or functionality of each block, and the one that concerns everybody would be what are essentially the signaling, the one that you mentioned in step 3, right? So it's just that my thinking is that to go in parallel with specifying pretty much what's the function or functionality of a block together with what they need to communicate, what kind of signaling. Otherwise, if we only specify signaling without understanding, without saying it, I don't think it's possible.
Morten Petersen. So I would say that I would probably prefer a different approach where instead of identifying the building blocks and saying what they should do based on these architectures, we rather go through the existing drafts, and when we say what is the building blocks in Tetris, what is the building blocks in the CSEV sliding window draft, and what are the interfaces, what do they have in common, can we come up with a generic description, because this will be an exercise of an imaginary system, which rarely produces, I mean it's not very, so I would rather say let's go through the drafts, do it on the mailing list, identify the building blocks in the current drafts, because that is where we know there are implementations, we know there's real systems that use these mechanisms.
Yes. So that was my intention when I started that discussion about what are the fields or control information that you are using in the different systems that have been developed. Start from there. Understand. So that was the bottom up. Then matching with so this group of signaling information, actually this subgroup fits into the reliability function. This other group goes into, say, congestion control function.
I think there will be some reuse of different components across different use cases, but I don't think we're going to be able to define a signaling interface that's going to be the same for all use cases. That's not
the same. No. Of course. I mean, some of them will be using Windows, some others would be using block, and definitely there will be some options there. But they both fit in this, let's call it super block maybe. It's a super block of reliability, and therefore the algorithms we're going to suggest not specify, but there is some signaling related to reliability that is clearly not for, congestion control or forward.
Okay, Marie-José again. I completely agree with Morten. Please do what Morten is suggesting. Yes. This is what I suggested in my the words I sent last week that nobody replied to. Look at what we have. There's a number of implementations. There's a number of proposals. What are these things using? Is there a way to have these things have common things that are going to be different, things that are going to be their implementation? We cannot start from a vision. And then again, going back to Frank's dissemination, if we have this complete complex document, how can we go to Manet? How can we go to the ICRNG guys? How can we talk about stuff if it's not related to the things that we can actually give them?
So that list of stuff that you're talking about, I started on the mailing list. Cedric added, and some others added. Yeah.
The architecture document, and this is what I was trying to say earlier, can play a role for sort of a top-down guidance.
Yes.
But it is not going to be a mandate.
Of course, yes.
And I think the actual designs are going to be driven, as Morten says, from the bottom up, from what we need from these things. I don't think it's going to be that useful to go through an exercise where we attempt to specify and derive from a top-down approach.
It's not a top-down.
What's the objective of this? I don't understand.
To understand, okay, so the objective, so we should have started with that,
Because I do understand the objective of identifying something like the picture on the left with respect to having a fairly high-level, like I said, guidance for what are the different components of network coding systems to help communicate with the outside world and everything. But I don't think we need to continue the exercise much further down below that. And I think that's what Vincent was saying. Do I understand you, Vincent, or?
Okay, so let me see if I understand. So you're saying that the internal communication or interfaces, it's not needed, and I agree with that. It's the external signaling that I understand. Without that, there is no protocol, right? So I agree with that. I try to follow the way the norm building blocks, and maybe it was not the best, but that's the example of building blocks that I had. So, okay, so let's.
And I think I made a comment earlier on with respect to our version of building blocks here versus what we did in RMT. RMT was a much more finitely scoped case. So the building blocks there, if you will, were sort of at a different level of abstraction and a little tighter than what we're doing here. And I think I actually had proposed another term. I can't remember it. I have to go back and look at the slides, like functional areas or something like that.
Okay, yeah.
And I think the architecture can kind of describe those functional areas, but we don't.
Yeah. So maybe these are
bottom-up approach to get.
So maybe these are functional areas or mega blocks, if you want, instead of.
Building blocks can be defined from the bottom up. I agree with you.
Okay. Yeah. So let's rename the mega blocks or functional. Yes. Okay.
Yeah. So Bhumip Khashnavish. So I think what we need is a high-level functional block diagram, not showing all of it, maybe 3 or 4 blocks, and then show the use cases where. That way, the way you are putting now, it will scare people away. They will not look at it. They will say it's too complicated.
Flip back, is that what you're looking?
Yeah, no. See, in each of the block, you already put too many colors. So without putting that, too many colors and too many names, it's too crowded already. So if you can say app, TCP, shim, and then IP, just 4 blocks. And then you show the use cases, like for reliability, this is how this architecture can be used, 4 or 5 use cases.
Yeah, I guess one thing that I did think was valuable in the architecture document was to definitely start with a very simple diagram, but possibly decompose that.
Decompose it,
shim
as you go on.
What I called functional areas.
Functional, but
reliability, congestion control.
Yes. The thing is, if you put all these things in the first diagram, people get scared and confused.
The building blocks themselves, the definition of those should be driven from the bottom up.
Yeah.
They might. In the document of the building block, you might say, hey, I related to this architectural functional area just to kind of provide a reference point
That's correct.
in the architecture for that building block, but it's not a normative specification or anything like that. And I think that's maybe Victor.
It's just a terminology, right?
You don't want to make this architecture document too hard. It's never going to be right anyway.
Of course.
It's because it's going to evolve, and so let's just. Stick a fork in it, and with the drawings, and not go too heavy on.
Too heavy from the beginning, from get-go.
Okay, thank you.
The rationale to do this, let me tell you the main rationale I was proposing this, and I thought I saw this in, maybe I saw a little something different than what's actually there in norm.
But again, it's a different level of...
I understand. So here's a big rationale for this, is decoupling, for example, the reliability function from the congestion control function. We had all the discussions, not just this meeting, but some meetings ago about how do you do congestion. So this would basically be a function that is separate from whatever reliability you want to do.
I don't think the top-down architecture can mandate whether or not they're decoupled or not in a specific protocol instantiation. You might have a protocol where that's the case, a use case where that can be true, but it's not going to universally apply. So I think it's going to be just a waste of time to try to have the architecture achieve that type of goal.
So the only thing that you
down
can...
at the building block document, we could do more of that, but not in this architecture. Yeah.
I will suggest something so that we get out of this.
Yes.
We called it a marasme in French. If somebody knows the English word, please send it to me. Why don't we, until the next meeting, start a discussion on the list about what the current implementers think are their building blocks?
Yes.
So,
and that's completely separate from
very
this.
simply, these are the building blocks that my implementation is using, and here are things that I could create interfaces to, or APIs, or name it. I like the word API, but it's because it's my world. And then we have everybody responds to this. Then we'll see, okay, please implementers, not you doing the job. Please implementers, go back and see what your different building blocks have as differences and sort it out. And then at the next meeting, maybe we do a little workshop and we come up with one document, and then we're done. Because as long as it's you reinterpreting what the developers are doing while they're still moving on with their development, you'll always be behind. You'll always work really hard, but you'll always be behind. And the implementers like Morton and like Jonathan and probably whoever's going to work with me, we're going to tell you, yeah, but this was like last year's implementation or whatever, and you'll never be current. Yeah. Let's have the people who do the development do the work.
Right. Okay. So I understand. I agree with that. So the intention here was to find a common way to interoperate. Basically, having some kind of a common signaling, if we can do that, so that we can actually talk about a family of protocols.
I don't think you're going to have a common signaling across all use cases, even for some of the same.
What I'm saying is it will be option. For example, you're not going to use block and window the same, so it's going to be an option to that.
That shouldn't be done at this top-down level.
Okay.
It can't be.
No, yeah.
Okay.
I totally agree.
Okay.
Morten Petersen, I totally agree with that.
Sure.
I mean, the signaling will come by looking at the drafts, figuring out what is in common, and
so okay.
Doing signaling.
So what I'm trying, the main goal here is to get some kind of a common way of doing things as much as possible.
Yeah,
so otherwise it would be a smorgasbord, everything.
And I wouldn't say even a common way of doing things. My viewpoint on the architecture document again was to just identify the functional areas so we have possibly a common way of framing the problem that the different use cases and instantiations are going to tackle. It's just about framing the problem, and then that way when you write a building block document that you hopefully derived from your protocol specification, you could say this building block applies to not just one, but possibly multiple functional areas. And just to provide a point of reference.
I understand. Okay, so my terminology of building blocks is really functional
and we went
area.
This
Yes.
last time.
Yeah. Okay. Function mega block functional. Okay. Yeah. Okay. So let me finish with where I started. Let's see how we can converge. Okay. So getting. I'm listing here, and I'm trying to tease out the main function of reliability. For example, it's going to take on the, it's not, so in this view, reliability is not responsible for coding. There is one part of another module or functional block or that takes care of all the coding, testing for innovative, any kind of coding, decoding operation, and reliability is responsible for making sure things are reliable in some certain sense. There are many ways of getting reliable, semi-reliable transmission, but transport, but that's sort of the home of that function.
Just so you know, we are past our time slot. So
okay. Already? Okay. So that's why, for example, the ones who have used it in the, who have developed it in the past, this is an example of the signaling that goes on at the reliability level. If you go on the forwarding, this is the functional area where packets are actually created out of coded symbols. Vincent mentioned that you could have, for example, multiple coded symbols in a packet. The main responsibility for this is to decide when to send, where to send, and it's the what to send comes from the reliability module, and also it's the indication of when to send is also it's coming from the rate control indication from the congestion control module. Moving on to the congestion control, this would be very much reusing stuff that was already researched and specified, such as the unicast and the multicast congestion control. There is one area that I understand that there is no such, that there is still research that needs to be in the general graph or subgraph case, directed graph. So. Last but not least is this security. Is it a building block or just a factor or consideration? Definitely there are, and some of you that talked before were mentioning how to add encryption, combine it with coding. That's a field that is interesting and important. Identify the vulnerabilities and the different mechanisms that may apply to different functional or building blocks. Is there any other slide? Probably not. Oh, yes. Okay, so the next steps, I think it's pretty much what Vincent suggested, the draft. So what I'm proposing is to have a draft on network coding architecture, and related to that, some of the building blocks that we will identify based on this architecture.
And I think the consensus is pretty much the opposite of your last bullet here, which is
really
it'll be about
meaning this.
Yeah, taking our protocols and seeing what the building blocks are in those protocols.
Okay.
And in my opinion, the functional area, almost everything you said, I would call a functional area.
Okay.
It's just a simple mapping of, hey, this protocol has these building blocks. Building block 1 relates to this architectural functional area building, and be done. And I think we are probably overstaying our room.
Okay, thank you everybody for coming here today.
Make sure that you sign the blue sheets, and we would like to get the minutes and or Jabber archive from folks too for assembling minutes for the meeting. Thank you. Hey, best meeting yet. They get better every time.